So I think in the last class we discussed about the geometry. Okay, we discussed about the types of arrangement of these two types of solids, namely crystalline amorphous solid. वो सब discuss किया था ना हम लोग ने. I think that was clear. Till there it was clear, I suppose, all of you. Okay. So today we are going to discuss a few points out here. So first तुम लोग लिखो तुम्हारा space lattice, and unit cell. So space lattice and unit cell. Okay, we are going to discuss here space lattice and here unit cell. Okay. So in a crystalline solid, क्या था? There is a regular arrangement of constraint and discussed though in a crystalline, yes, we can say space lattice. What is this space lattice? What do you mean by space lattice? Okay, have you heard of this point lattice before? Huh?
Yes, sir.
So lattice energy.
Lattice enthalpy.
Lattice. Okay, good. Okay. Yes, we have heard it. So what does this point lattice mean? Huh? First, let me try to define this lattice. Okay. So just write it down quickly. Lattice. The positions which are occupied by the positions. Okay, the positions which are occupied by the positions which are occupied by what? The positions which are occupied by either atoms, molecules, or it may be ions as well. The positions which are occupied by atoms, molecules, or ions are called lattice points. Right? These are called lattice points, or sometimes they're also known as lattice sites. They're also known as lattice sites. Okay, and these lattice points normally, they are normally indicated by a dot line. Okay, lattice points, they are indicated by a dot. So what is the lattice? So the positions which are occupied by atoms, the positions which are occupied by molecules or ions are called lattice points or lattice sites. Okay, so lattice point means there should be a regular arrangement, right? And this arrangement or positions are shown by some dots which are known as a lattice points. Okay, for example, so if I draw a points at regular intervals like this, if I draw a points at regular intervals, what does this represent? These represents a lattice points along one dimension, along a line. This represents a lattice point along one dimension. Okay, so these points are known as lattice points, and at these points, what are present? Some atoms or molecules are present. Okay. Now, if I draw an arrangement of particles along two dimensions like this, say if I draw points like this, there's a regular arrangement. So yes, there is a regular arrangement of lattice points, and this is the arrangement of lattice points along how many dimension? Along two dimension, along x-axis, along your y-axis. So this represents the lattice points along two dimension. Is it possible to draw the lattice points in three dimension in code? Is it possible? Three dimension मतलब क्या हुआ? I must take one more axis like this, right? So there must be lattice points out here as well, right? यहाँ पर भी lattice point होना चाहिए. Is it possible to draw? No.
No.
So, but let me try to draw it. Okay, let me try to draw it. So I'm drawing some lattice points out here. I'm drawing some lattice points out here. कौन सा dimension में draw कर रहा हूँ मैं guys?
2 dimension.
Along the which dimension? Along 2 dimension. 3 dimension में क्या होगा इस technique? 3 dimension में क्या होगा? So there is a lattice point at equal distance above this. इसका आगे भी एक होगा, इसका आगे भी एक होगा, इसका आगे भी एक होगा. So there is some lattice point out here. यहाँ पर एक lattice point, यहाँ पर एक lattice point, यहाँ पर एक lattice point ना, इसके आगे lattice point. Okay. So let the lattice point at the front be represented by this. So आगे जो lattice point है, let it be represented by this. So if you have any issues, just let me know.
Yes, sir.
So what does this blue line indicate? मैं तो ये 3D तो नहीं बना सकता हूँ मैं. So I'm representing this blue line represents the lattice points above these. इसका आगे जो lattice point is represented by this blue. ठीक है?
Yeah.
Now always remember the lattice points are always joined by straight lines. So we always connect the lattice points by straight line like this. We connect the lattice point by straight line. Okay, the lattice points are always connected by straight line. They are always joined by straight line like this. Okay, they are always joined by straight line. So let us join by straight line again. So let me join by straight line. So I can join this. I can join this. I can join this. I can join this too. I have this. Okay, I have this. Fine. Fine. Now again, I'm joining these lattice points. I'm joining these lattice points. Okay. Fine. Again, I'm joining this lattice points. See, मैं सब join कर रहा हूँ. Lattice points, remember, they are always joined by straight lines. Hey. So these are the lattice points along which dimension? Along 1 dimension, 2 dimension, or 3 dimension? We have joined along 3 dimension. Hey, 3 dimension जैसा दिख रहा है. Okay, so what do you mean by space lattice? Hey, it is the 3-dimensional arrangement of identical points. A space lattice, space मतलब है 3 dimension. Space मतलब 3 dimension. So space, the lattice points may be arranged along 1 dimension. It may be arranged along 2 dimension. It may be arranged along 3 dimension as well, right? Okay. So the 3-dimensional arrangement of identical points in the space. So chalo, let us start on the definition now. Okay. So I have फिर से मैं सब lattice points को connect करूँगा तो ऐसा pattern आएगा नीचे भी. Okay. So लिख लो. Write down the definition. Write down the definition. Yes, tell me.
That blue dots you told me, what is that?
These blue dots represent the lattice points above these. इसके आगे जो होगा, it is represented by these blue dots. It is represented by the blue dots. 3-dimensional में, ठीक है? It is represented by blue dots. मतलब these are in a one plane. ये चारों dot इसके आगे, इसके आगे, इसके आगे, इसके आगे. So actually it is like this. It is actually like this. दो इसके आगे, दो इसके आगे. Okay. So it is the 3-dimensional arrangement. It is the space lattice. It is the 3-dimensional, like, ठीक है, 3-dimensional arrangement. It is the 3-dimensional arrangement of identical points in the space. Of identical points in the space. It is the 3-dimensional arrangement of identical points in the space. It is a 3-dimensional arrangement of identical points in the space, which represents how the particles which represents how the particles means what? What do you mean a particle? It can be, I told you, I have been telling you, it can be atoms also, it can be molecules also, it can be ions. It represents how the particles are arranged in a crystal. These are known as a space lattice. So it is the three-dimensional arrangement of identical points in the space which represents how the particles are arranged in a crystal. So these are known as a space lattice. These are known as a space lattice. Okay, now
Yes.
जो मैंने तुम लोगों का टू डायमेंशनल स्पेस लैटिस टू डायमेंशनल जो अरेंजमेंट बनाया था, and last में I think I connected the points as well, na guys?
Yes, sir.
I connected the points, na? So after connecting all the points, देखो it's so easy to understand. So lattice points समझ में आ गया तुम लोगों. And remember the lattice points. Do you join the lattice points by a curved line, key straight line? Always a straight line. So these are the lattice point, means these positions are occupied by particles. Right? Okay. Now, if I join the lattice points, I see the entire arrangement is made up of some identical shapes out here. What is the identical? What is the smallest unit out here? It's a square. So if I connect all the lattice point, I can visualize this as many squares stacked together. This is formed by the repetition of many squares. Can I say? Yes, it is formed by the repetition of many squares. So here also, on connecting all the lattice points in space, I get the smallest repeating unit out here. What is the smallest repeating unit? यहाँ पर कौन सा unit repeat हो रहा है बार बार बार?
Lattice.
What is the repeating unit? A small
Cube.
A small cube.
Cube.
A small
Square.
cube is getting repeated over and over again. यहाँ पर a
Small
small square is getting repeated over and over. यहाँ पर a small cube is getting repeated over and over again. So this smallest repeating unit is known as a what? Yes, it is known as a unit cell. It is known as a unit cell. Okay. So how do we get a unit cell? First of all, after joining all the lattice points, okay, we get the smallest repeating unit. After we join all the lattice points in space, we see a pattern which gets repeated over and over again. That smallest repeating unit is known as a unit cell. So a unit cell is defined as the smallest repeating unit, which when repeated over and over again generates the crystal. Then is the entire crystal lattice. So it is the smallest repeating unit. For example, all of us seen this Rubik's cube now.
Yes, sir.
So Rubik's cube, we can visualize a Rubik's cube. It is made up of many small cubes. So those small cubes in a Rubik's cube is the repeating unit. So those are getting repeated over and over again. So these smallest repeating units are known as a unit cell. Got it? What is a unit cell? Okay. So how do you get a unit cell? By joining the lattice points. Okay. By joining the lattice point. If you join the lattice point along 2 dimensions, you get a unit cell square. If you join the lattice points along 3 dimensions, you get a unit cell in the form of a cube. Okay. So this is the concept of a unit cell. And a unit cell, remember, it is characterized by 6 parameters. There are 6 parameters to characterize a unit cell. Okay, so we can say a unit cell यहाँ तक ठीक है तो? Till here it's okay?
Yes, sir.
Any questions till here? पक्का?
Yes, sir.
पक्का? Okay, fine, good. So, a unit cell is characterized. A unit cell is characterized by number one, your age length. Age length, which is denoted by A, B, and C. Okay, it is characterized by age length, A, B, and C. And angle between the ages, or interfacial angles. Interfacial angles, alpha, beta, and gamma. Okay, alpha, beta, and gamma. So depending upon the age length and these interfacial angles, the entire crystal system, there are 7 crystal systems, right? Depending upon these parameters, there are how many? There are 7 crystal systems. So there are how many? Yes, there are how many? 7 crystal systems. So there are 7 crystal systems altogether. Okay. Now what does this mean? Okay, so I'll just take out one small unit cell from here, right? Okay, I'll take out one unit cell. So unit cell means what does a unit cell look like? It looks like a cube, right? It looks like a cube. A unit cell now looks like a cube, right? A unit cell now looks like a cube.
Sir,
It looks like, okay, right?
sir,
So what are the lattice points from here? These are the lattice points, right? Suppose the particles are present now, okay. Okay, now in a simple cubic cell, your cube means all the 3 sides are equal, na? Length, breadth, height, A, B, C. These are known as A, B, C, A, B, C, whatever is length. So in a simple cubic cell, A equals to B equals to C, and alpha is equal to beta is equal to gamma is equal to how many degree? Kitna degree hoga? What is the angle between the faces? These are known as your faces, eh? These are known as your faces.
90.
90 degree. These all are equal to 90 degree. Okay, so just a minute. Just a minute.
sir.
So this is a unit cell. It's a cubic cell. All the 3 lengths are equal in size, equal in length, and these are known as your faces. These are known as your faces. A cube has how many faces? A cube has how many faces?
6.
6. 1, 2, 3, 4, 5, 6. And here we can visualize these are the unit cells. So it is formed as a repetition of each smallest repeating unit is known as a unit cell. So there are 6 faces. How many corners are there? 1, 2, 3, 4, 5, 6, 7. There are 8 corners.
8 corners.
Yes. How many edges are there? How many edges are there?
12.
Huh? Good. How many edges are there? There are 12 edges. Right?
12.
So depending upon the edge length, depending upon these edge length, and depending upon the angle between the faces, it has been characterized into 7 crystal systems. Right? And out of these, the simplest one is a simple cubic cell where all the 3 sides are equal and the 3 interfacial angles are also equal and the value is equal to 90 degree. अब तुम लोग बोलोगे, अब देखो, Now what I do is इसको मैं ऊपर के तरफ खींच लूंगा, मतलब ये है. Now imagine I am pulling this upwards, right? ये सेम है, बेस सेम है, जस्ट इसका जो हाइट है मैं इसको इंक्रीज कर रहा हूँ. ये I am pulling this upwards, मैं इसको ऊपर खींच रहा हूँ. So how does it look like? So it will look like this. यही को मैं इसी को मैं ऊपर की तरफ खींच रहा हूँ like this. I am pulling this upwards, right? So will it look like this?
Yes, sir.
Yes, guys. Okay, now you tell me the relation. Now you tell me the relation, eh? Tell me the relation now. Yes. Two. ये तो चेंज नहीं हुआ, बेस तो चेंज नहीं हुआ. So A is always A is still equal to B. But A, one of the side is elongated. So is it equal to C? Is it equal to C? यहाँ पर तो सब equal था. No, it's not equal to C. It's not equal to C. But what about alpha, beta, and gamma?
Same 90.
They still are equal to. They still are equal to 90 degrees. So this is known as a tetragonal. This is known as a tetragonal. The second crystal system is known as a tetragonal. ठीक है? Fine. अच्छा, now तुम लोग imagine करो एक मैच बॉक्स. चलो imagine करो मैच बॉक्स. है पास में मैच बॉक्स. Do you have a match box? रुको मैं लेके आ रहा हूँ.
Yes, sir.
No solid, no solid का मेरा voice.
होगा ना सुदान. Sir.
Match box, huh? Top match box.
Sir.
Imagine. Now you tell me what is the relationship between the three lengths match box में. This एक edge length, ये एक
yes,
edge
sir.
length, ये एक edge length. What is the relation? एक edge, एक edge. What is the relation? क्या है relation? एक edge length, दो, तीन. What is the relation? ये और इसके बीच में relation क्या है? बोलो. There's nothing to think.
Nothing is equal.
हाँ. क्या हुआ?
Sir, किस number?
What is the relationship between the three edges in a matchbox? Matchbox में what is the relation? ये एक edge length हुआ, ये एक edge length हुआ, ये एक edge length हुआ. So what is the relationship?
All are connected to same lattice point.
So यहाँ पर A is not equal to B, which is not equal to C. Is it so? हाँ. Neither of the sides are equal matchbox में. All are unequal. A is not equal to B, not equal to C. But again, alpha equal to beta equals to gamma. It is equal to 90 degrees. So this is known as your orthorhombic. Orthorhombic. So matchbox is an example of an orthorhombic system. Matchbox is an example of an orthorhombic system.
Sir,
okay, it's an example of an orthorhombic system.
It means cuboidal. Sir, cuboidal just to.
Yes.
Like cuboid just okay.
Cube तो क्या है? Cube तो ये. Cube मतलब ये all sides are equal.
Yes sir.
यहाँ पर none of the sides are equal. Matchbox. एक matchbox लेके देखो ना, पता चल जाए. But all the interfacial angles are equal to 90 degree. ठीक है?
Sir.
अब तुम क्या करोगे? कितना हुआ? 1 2 3 है. अब तुम सिंपल क्यूब पर ऐसा स्लैंट कर दो. सिंपल क्यूब को तुम स्लैंट कर दो ऐसा. सिंपल क्यूब ही है, तुम अब स्लैंट करोगे ऐसा. क्यूब को तुम स्लैंट कर दोगे ऐसा ना. तुम इमेजिन करो और मुझे रिलेशन दो. क्यूब ही है लेकिन क्यूब को तुम ऐसा मतलब स्लैंट करे मतलब ऐसा. What is the relationship between A, B and C? What is the relationship between A, B and C?
A, B,
QB, बोल रहा हूँ QB.
A equals to B
A equals to B equals
A,
to C,
no.
but alpha is also equal to beta is also equal to gamma, but is it equal to 90 degree or not equal to 90
No,
degree?
sir, not equals to 90.
No, sir. No.
It's not equal to 90 degree. ये हुआ तुम्हारा rhombohedron. Rhombohedron. ठीक है, so कितना हुआ? 1, 2, 3, 4. So just like this, there are 3 more in NCERT. NCERT में देखो एक पेज में along with the diagram it's given 7 crystal system. So my point is that on the basis of your edge length and their interfacial angles, the crystals can be divided into 7 crystal systems. So out of the 7, I have drawn 4. ये याद कर भाई. Matchbox is an example of an orthorhombic system. A matchbox is an example of an orthorhombic system. Okay. So
Sir,
तुम्हारा monoclinic है, triclinic है, देख लेना वो. Okay, it's given in your NCERT. Please go through it. It's given in your NCERT. Okay.
sir,
Till here it's fine. On the basis, unit cell, on the basis of what it has been classified, it has been classified on the basis of edge length and angles. Right? कितने में 7 crystal systems में. Simplest क्या है? एक simple cubic cell. Simple cubic cell में क्या है? We know a cube. Okay, perfect cube. So all the sides are equal. All the bond angles are also equal to 90 degree.
yes, sir,
Okay.
sir,
Okay, fine. Good. Yes.
sir. Hello.
बोलो.
Sir,
Bipin and Aish had
Yes,
questions.
I can hear you.
Yes.
A unit cell gets repeated over and over again. Okay, जैसे imagine this to be a crystal. Imagine this to be a crystal. What is this entire crystal made up of? It is made up of many small cubes like this. So each small cube is known as a unit cell. And unit cell maybe there are there are atoms. Right? There are atoms which are arranged in 3 dimensions. And these 3-dimensional arrangement of atoms are known as a space lattice. A unit cell is made up of space lattice, right? And when the unit cell gets repeated over and over again, we get a crystallite. What is a unit cell made up of? Obviously, unit cells are made up of lattice points. Unit cells are made up of lattice points. How is a unit cell made of? Unit cells. When you connect the lattice points by a straight line, you get a unit cell. That's it. तुम जब लैटिस पॉइंट्स को स्ट्रेट लाइन से कनेक्ट करोगे यू गेट अ यूनिट सेल है. Okay, fine, understood?
yes,
Yes,
sir.
sir.
Okay, fine. Now the main thing है, now whoever will understand this, ये chapter खत्म. Okay, now you should understand this. Obviously this has to be understood, right? This has to be understood. Okay, चलो. Now depending upon the position of atoms, right? Okay, depending upon the position of atoms, again a unit cell is classified into 2 broad categories, right? Depending upon the position of atoms, unit cell is classified into 2 categories. एक है तुम्हारा primitive unit cell, and the other is non-primitive. Hey, whoever have a problem in understanding this, please let me know. Hey?
Yes, sir.
एक तुम्हारा primitive बोलते हैं, एक non-primitive. Okay. So what is a primitive unit cell and what is a non-primitive unit cell? Okay. So as per the definition, a primitive unit cell is defined as one. Okay. So in these unit cells, the constituent particles are present only at the corners. Okay. Gaussian particles कहाँ पर होगा? Corners में. How many corners are there? How many corners are there?
8.
कितना corners है again? So where are the particles present? Primitive unit cell में यहाँ पर एक, यहाँ पर एक, यहाँ पर एक, मतलब 8 corners में 8 particles है. So non-primitive में क्या होगा? In addition to the corners, the particles
कि भैया मतलब मेरा नेटवर्क मिस लाइक
so you can see the board. Okay, so
Yes, sir,
non-primitive
clearly.
in addition to the corners, the particles are present at the other points as well. Like, okay, so corners में तो है ही है, but in addition to the corners, the particles are present at the other positions as well. Like, so corner में छोड़ के भी particles are present at the other positions. Yes. Can you let me know what are the types of non-primitive? What are types of non-primitive unit cell? Yes, you have done this in your school. The number one is here.
Face-centered unit.
It's abbreviated as FCC. Second is here. Body centered cubic cell. It is known as here BCC. And the third is known as here end centered. And primitive में एक simple cubic cell. SCC. Okay, so simple classification on the basis of positions of particles. Primitive में the particles are present only at the 8 corners. Non-primitive में in addition to the corners में तो है ही है. In addition to the corners, the particles are present at the other positions as well. Okay, corners में तो है ही है. Corners छोड़ के भी the particles are present at the other positions. So these are the classification. So since you have done it already in your school, okay, so I think this will be more easier for us to understand. So now I'm going to draw all these 4 types of unit cells. Okay, so I'll rub this. Can I rub this now? I'm rubbing this. Okay, I'm rubbing this. So I'm just rubbing this. Okay, now, so let me draw a simple cubic cell first. So I'm trying to. Okay, so where are the particles present, guys? Where are the particles present? The particles are present only at the corner. The particles, what does this denote? This denotes the particles. It may be atoms. Okay. So this comes under here SCC, simple cubic cell. Okay. It's so easy. Don't leave, eh? Don't leave. नहीं तो solid state का सिर्फ वो समझ में आएगा तुम लोगों को. Okay, so FCC में क्या होगा? In addition to the corners, corners में जो है ये, corners में जो है particles, the particles are present at the corners, right? Okay, so in addition to the corner, the particles are present at the center of face. मतलब एक particle, चार corner, 8 corners में 8 particles है. And in addition to the corners, there are particles at the center of the face. Face हुआ, face का center ये हुआ. So one particle is present. Okay. So how many such particles are present? So altogether there are 6 particles at the center of 6 faces like this. There are 6 particles at the centers of 6 faces. ये आगे वाला फेस है, इसका सेंटर यहाँ पर होगा. ये पीछे वाला फेस है, इसका सेंटर यहाँ पर होगा. So this is known as your FCC, face centered cubic. So in addition to the corners, in addition to the 8 corners, there are particles at the center of 6 faces. There are particles at the center of 6 faces. Okay. Yes, you can ask me if you have anything which is not clear, because this should be clear. ये clear नहीं हुआ तो बस solid state हो गया. If this is clear, it's too easy from here onwards. Okay, so again I have 8 particles at the 8 corners. 8 corners में I have 8 particles like this. Like this. And imagine cube का बीच में, not at the face. Cube का जो बीच में one particle is present at the center of the cube. मान लो ये room in which you are sitting right now is in the form of a cube, right? Right. Now imagine करो एक ball, football ball room का बीचों बीच में. So that's a body centered cube, right? इसको हम लोग बोलते हैं body centered cube. BCC, body centered cube. Okay. Now last में n centered है. अच्छा, n centered में होता क्या है? Again, 8 particles at the 8 corners. 8 particles are present at the 8 corners. Okay, and there are particles which are present on 2 alternate faces. मतलब particles may be present out here, out here, out here, out here. So I'll just draw एक particle यहाँ, एक particle यहाँ. End centered. Okay, so this is the end centered. So यहाँ पर ये particle. So particle, you have to imagine. Okay, I forgot to tell you. You have to imagine that the particle is in form of a sphere. Right? The particle is in form of a sphere. It's like a ball. It's a sphere. Right? The particles are assumed to be spheres. Right? And always remember, हम लोग कौन सा chapter पढ़ रहे हैं guys? कौन सा chapter पढ़ रहे हैं हम लोग? Liquid state की solid state हो?
Solids.
तो solid state में मैंने first class से बोला था. In a solid state, the atoms are closely packed, ना?
Yes, sir.
बोला था मैंने. But यहाँ तो why these atoms are not touching each other? Okay, actually these atoms are always touching each other. Right? They are always in contact with each other, right? But in order to make you understand, they are kept separated. If I just draw these touching each other, you won't be able to understand. But remember, very vital point, these atoms are always in contact with each other, right? These atoms are always touching each other. These atoms are always touching each other, right? Here, these 4 atoms are touching each other, this is touching each other, this is touching this, all these are touching each other, right? Okay, so till here it's okay, fine,
Yes, sir.
perfect. कोई issues यहाँ तक? So यहाँ पर just remember classification is done on the basis of position of particles. right? सिर्फ corners में है तो simple cubic, corners और center का face का center में है तो face center, corner और body का बीचों बीच में है तो body center. बस ये कुछ रट्टा नहीं मारना पड़ेगा. एन सेंटर मतलब ये तो सिलेबस में ये भी नहीं, 8 कॉर्नर्स में है और एन इनटू अल्टरनेट फेसेस.
Yes, sir.
Okay, so just let me show this. Let me just show this तुम लोगों को. Just a minute, just a minute.
Centered unit cells. When constituent particles are present not only at the corner positions, but also at some other positions within the crystal, then the cell is known as centered unit cell.
It's non-primitive also. Okay.
Centered unit cells are further classified into body-centered unit cell, face-centered unit cell, end-centered unit cell. Body-centered unit cell.
देखो.
In this type of unit cell, one constituent particle, such as atoms, molecules, or ions, is present at the center of the unit cell, in addition to the particles present at the corner positions. Body-centered unit cell is denoted by the letter I. In face-centered cubic unit cell. In this type of unit cell, the constituent particles are present not only at the corners, but also at the center of each face of the unit cell. Face center unit cells are denoted by the letter F.
Please feel free to ask me any number of times, but you need to understand the same. Okay, I'm talking about a unit cell till now. I'm talking about a unit cell. But in a crystal, how many unit cells are present? How many unit cells makes up a crystal? Infinite number of unit cells. जैसे ये एक crystal है. This crystal is made up of how many unit cells? There are many unit cells. There are many unit cells like this. And देखो, I'll just tell you, imagine. So यहाँ पर देखो, okay, you see out here. So each unit cell is in contact with other unit cell.
Yes,
Yes
sir.
or no? Each unit cell is in contact with other unit cell. मतलब ये जो unit cell दिखाई दे रहा है बीच में red, it is in contact with how many unit cells? This unit cell is in contact with how many unit cells? Huh?
2, 3, 4.
It is in contact with how many unit cells? देखो ना, 1 इसके साथ
One.
contact में है.
Yes,
1,
sir.
then
2,
2,
3,
3, 4.
4. Yes, sir. 4.
It is in contact with 4 unit cells. It is in contact with 4 unit cells. I like to say.
Yes, sir.
Right. A unit cell. So we are saying that we are trying to say that a unit cell is in contact with many unit cells. Right. So this unit cell is in contact with this unit cell. Yes, the unit cells are in contact. So are these particles? Does this particle belong to a unit cell or is it shared among many unit cells? Does it belong to a particular unit cell or is it shared among many unit cells?
Shared among many units.
I'll just give you one simple example. I'll just give you one simple example. Okay. I'll just give you one simple example. Okay, I have drawn how many unit cells out here? I have drawn how many unit cells? 2. I have drawn 2 unit cells. Okay. So if I have a particle out here, if I have a sphere out here, it is shared by how many unit cells? This particle is shared by how many unit cells?
1, 2, 3.
This particle is shared by how many unit cells?
4
It is shared
units.
by this unit cell. It is, yes, it is shared by 2 unit cells. It is shared by this, it is shared by this.
अच्छा, units in this.
This is also shared by this, it is shared by that. Right? Got it?
Yes, sir.
Now, in a crystal, it is not only made up of 2 unit cells, right? इसके आगे भी ऐसा एक यूनिट सेल है, इसका आगे भी ऐसा यूनिट सेल है, इसके आगे भी तो ऐसा यूनिट सेल है ना, इसके आगे भी तो ऐसा यूनिट सेल है. We have one more unit cell in front of this. एक यूनिट सेल तो इसके आगे भी ऐसा है, एक ही नहीं?
Yes, sir.
इसके आगे भी तो ऐसा यूनिट सेल है, इसके आगे भी ऐसा यूनिट सेल है, इसके आगे भी. So this is shared by how many unit cells now?
4 unit cells.
4 unit cells. Good. It is shared by ये वाला, ये वाला, ये वाला, ये वाला. 4. इसके ऊपर भी तो ऐसा यूनिट सेल है, ये कि नहीं? इसके ऊपर भी तो ऐसा
Yes,
यूनिट सेल
sir.
है. इसके ऊपर ऐसा यूनिट सेल है,
Yes, sir.
इसका ऊपर ऐसा यूनिट सेल है,
Yes, sir.
इसके ऊपर भी ऐसा यूनिट सेल, इसका ऊपर भी ऐसा
Yes.
यूनिट सेल. Now you tell me, a particle at the corner is shared by how many unit cells?
8 unit cells.
How many?
8.
मैंने यहाँ पर दिखा दिया, this is shared by 4 unit cell, right? अब ये 4 का ऊपर भी ऐसा यूनिट सेल, इसका ऊपर ऐसा यूनिट सेल, इसका ऊपर ऐसा, इसका ऊपर ऐसा, इसका. So it is shared by how many unit cells? A
4
particle
plus
at the
4.
corner is shared by how many unit cells? 4. तो यहीं पर शेयरिंग हो रहा है, इसका
हाँ.
और ऊपर 4 है. So
4
total how
plus
many?
4, 8. 8 unit
8.
cells.
Yes, a particle at the corner is shared by 8 unit cell. So 8 unit cell. Okay, so one corner particle is shared among 8 unit cell. So what percentage of a particle belongs to a unit cell then?
1
A
by
corner
8.
particle. What fraction of a corner particle belongs to a 8 unit cell will share one corner particle. So one unit cell will get how much?
1 by 8.
1/8 of corner particle. So only 1/8 belongs to a unit cell. Right? So yeah, we are talking about a crystal now. So यहाँ पर तुम लोग सोच रहे हो, sir, this to belong to this unit cell only. But we are talking about a crystal. In a crystal, the crystal is made up of many such unit cells which are stacked together. And so we see that each corner particle is shared by 8 unit cells. Right? Got it? So 8 unit cells will share one corner particle. So one unit cell, okay, one unit cell may 1/8 of the corner particle belongs to a unit cell. 1/8 of a corner particle belongs to a unit cell. Is this understood or no? Yes, tell me. देखो सिंपल डायग्राम ये बनाया मैंने, पहले 2 शेयरिंग हुआ, इसके आगे एक यूनिट सेल है, इसका आगे. सो आई कैन ड्रॉ लाइक दिस, नो वरीज. इसका ऊपर भी आई कैन ड्रॉ यूनिट सेल लाइक दिस, इसका ऊपर भी आई कैन ड्रॉ यूनिट सेल लाइक दिस, इसका ऊपर भी आई कैन ड्रॉ यूनिट सेल लाइक दिस, ऐसा. So it is shared by, इसका ऊपर भी, इसका आगे. Okay, it's hard to draw, that's why I'm explaining you like this, right? ठीक है. I'll show you, don't worry, I'll show you a 3D. चलो,
Yes, sir.
ये हो गया. Again I'm drawing it, हाँ. तुम लोग अभी बोलो, सिर्फ बोलो मुझे, ठीक है? You just tell me whatever you have understood. अच्छा, so how many unit cells have I drawn?
2 unit cells.
2 unit cells. Good, fine, excellent. ठीक है, 2 unit cells. Okay, now just have a look. Okay. So I have a particle out here. मतलब कहाँ पर है? Where have I drawn a particle?
Between 1
Where have I drawn a particle? What does this represent? Face.
face.
Face. A particle is present at the center of a face. Right? Now you tell me, if a particle is present at the center of a face, this ball, this sphere, or this particle is shared by how many unit cells?
2.
2. 2 means what fraction of the particle belongs to one unit cell then?
1 by 2.
1/2, exactly. So the two unit cells shares a face-centered particle. A face-centered particle is shared by two unit cells. Okay, so I can just write down two unit cell will share one face-centered particle. So one unit cell will get what fraction of the particle it will get? So half face-centered particle will
Yes.
belong to one unit cell. Fine? ठीक है? Okay. चलो now कॉर्नर का पता है, कॉर्नर का कंट्रीब्यूशन हमेशा 1/8 होता है. फेस सेंटर का कंट्रीब्यूशन कितना है? वन पार्टिकल का कंट्रीब्यूशन कितना है टुवर्ड्स वन यूनिट सेल? हाफ है. कॉर्नर पार्टिकल का कंट्रीब्यूशन कितना होता है टुवर्ड्स वन यूनिट सेल? 1/8. अब ओके, आई एम जस्ट रबिंग दिस. मैं इसको रब कर रहा हूं. And I am drawing a particle at where am I drawing the particle? कहाँ पर draw कर रहा हूँ मैं particle? बोलो, where am I drawing the particle? At the, what are these known as? What are these known as?
Edges.
Edges.
Edges. Where have I drawn the particle? Where have I drawn the particle? At the center of a edge.
Edges.
At the center of a edge. So these edge center particle is shared by how many unit cells? It is shared by how many unit cells?
2.
2. अब मैं बोलूंगा नहीं, 2 क्यों? इसका ऊपर भी तो ऐसा ही है.
Yes, sir. Oh,
इसका ऊपर भी तो यूनिट सेल है,
4.
इसका नीचे भी तो यूनिट सेल है. So इसका ऊपर और नीचे भी तो यूनिट सेल है. ये ऐसा,
Yes.
right? So now you see it is shared by how many unit cells?
2.
ये 1 2
1, 2, 3,
ऊपर
4.
दो,
4. 4.
नीचे 2. It is shared by how many unit cells?
4.
4 unit cell. ये 2 unit cell शेयर कर रहा था, इसके ऊपर भी 2 unit cell है. So 4 unit cell, 1 edge-centered particle है. So 1 unit cell, 1/4 of edge-centered particle. So what fraction of a particle present at the edge centers belong to a unit cell? Only 1/4 will 1/4 of a edge-centered particle will belong to a unit cell. Okay, and now again I'm going to ask you a simple question. I'm not going to do this. Yes, guys, come on, chalo, concentrate. What fraction of this body-centered particle belongs to a unit cell? What fraction of a body-centered particle belongs to a unit cell?
1.
1. It is not shared by any other unit cell. ये तो cell के अंदर है. It is not shared by any other unit cell. So all of these belongs to this unit cell. Excellent. Okay. So ये चीज याद करना पड़ेगा. ये चीज याद करना पड़ेगा. So what is the contribution of corner particles? What fraction of a corner particle belongs to a unit cell? 1/8. What
1/8.
fraction of a face-centered particle belongs to a unit cell? Half.
Half.
What fraction of a particle belongs to a edge-centered? 1/4.
1/4.
What fraction belongs to a body-centered particle? 1.
1.
ठीक है? Is it okay?
Yes, sir.
All of you? Rahul? Aditya,
Yes, sir.
is it okay? Rahul, it's okay.
Yes.
Isha, it's okay. Okay, where is this girl? Is she logged off again? Okay. What's her name, Aditya? Okay.
Calculations of number of particles in a unit cell. A crystal lattice is made up of a very large number of unit cells. Each unit cell is touching a number of other unit cells. In a unit cell, every lattice point is occupied by one constituent particle. Thus, a constituent particle present at the lattice point may be shared by a number of unit cells. Let us now understand the contribution of a particle in a lattice point to its unit cell.
देखो ये ध्यान से देखो ये
A corner atom is shared equally by 8 unit cells. 4 unit cells are present in the lower layer and 4 unit cells are present on the upper layer. Therefore, each corner atom contributes only 1/8 atom to a particular unit cell. A face-centered atom is shared equally by 2 unit cells having a common face. Therefore, an atom present at the center of the face of a unit cell contributes half atom to each unit cell. A body-centered atom is not shared by any adjacent unit cell in a crystal lattice. Therefore, it contributes fully to a unit cell. A edge-centered atom is shared by 4 adjacent unit cells in the crystal lattice. 2 unit cells are present in the lower layer and 2 unit cells are present on the upper layer. Therefore, it contributes only 1/4 of itself to a unit cell. Calculation of number of atoms per unit cells in primitive cubic unit.
चलो so now we know the contribution of each kind of particle, right? So contribution of corner particles 1/8, the contribution of face-centered particle half, the contribution of edge-centered particle 1/4, the contribution of body-centered particle 1. Okay, so I can rewrite out here. What is the contribution of these corner particles? The contribution of these corner particles is 1/8. The contribution of this face-centered particle कितना है तुम्हारा? Face-centered का half. What is the contribution of this particle at the center? 1.
1.
Okay. So now the next vital topic is going to be the calculation of number of particles. Right? Calculation of number of particles per unit cell, like calculation of number of particles per unit cell. Okay, now देखो भाई, so in a layman's way, okay, so मतलब एकदम hard way से हम लोग करेंगे. What is the contribution of each of these particles? What fraction of this will belong to a unit cell? इसका what portion will belong to this unit cell? इसका
1/8.
1/8. So 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8. So if you add 8 times 1/8, how much will you get? इसका 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1 plus 1/8. How much will you get?
1.
1. So total 1/8, 1/8, 1/8, 1/8 करके हम लोग combine करेंगे तो simple cubic cell में there is one particle per unit cell. Okay. So number of particles per unit cell, this is denoted by the letter Z. So SCC में देखो, SCC में number of particles Z कितना होगा? What is the contribution of one particle? Yes, tell me again. 1/8. 8 corner particle का contribution 1/8. And how many such corner particles are there? How many such corner particles are there? 8. So 8 particle का contribution 1/8. So 8 particles contribution 1/8 into 8. So Z equals to 1. So there is 1 particle per unit cell in a simple cubic cell. Right? So in a simple cubic cell, the total number of particles per unit cell is 1. Okay. So if you calculate and get the value of Z as 1, you can conclude that it belongs to this simple cubic cell. Right? अब तुम लोग मुझे face centered का बताओगे. face center का चलो. What is the value of Z?
1/2.
8 corner particles है. So 8 corner particle का contribution 1/8. How many such corner particles are there again? 8. 8 का contribution 1/8 होगा. There are 8 such corner plus what is the contribution of each particle at the face center? कितना था?
1/2.
1/2. एक particle का half है. So how many face centered particles are there? How many face centered particles are there? एक का half है into 6. There are 6 faces. कितना आ रहा है? 1 plus 3.
4.
So therefore Z equals to 4. So for a FCC, the number of particles per unit cell will be 4.
So,
Okay?
so the 1/8 फेरि भन्दिनु के थियो?
1/8 is the contribution of one corner particle. मतलब only 1/8 will belong to this unit cell. 8 particle का 1/8. So how many such particles are there? 8 particles. So contribution of one
So the
particle
1/8
is
is your concentration, no?
1/8 into 8. Right? Okay now?
So
Okay, good. अब इसका बोलो मुझे BCC का बोलो चलो. You tell me and write it down.
Z is equals to 1.
Z equals to
1/1.
1 by corner का क्या होगा? 1 by
Corner 8.
into
8.
8 plus
1
plus 1 at the center is equal to
2.
1 plus 1. Therefore Z equals to 2. ना?
Yes, sir.
तो ये याद भी करना पड़ेगा. FCC में 4, BCC में 2. अब N सेंटर का बोलो हिसाब मुझे.
N center का
बोलो.
1/8 into 8 plus
Plus
1/4.
1/4.
1/2
1/4 क्यों? फेस
1/2.
सेंटर का 1/4 कहाँ से आया?
1/4.
फेस सेंटर का कितना?
1/2 into 2
1/2 into
2
they are present only at the two faces, right? Into 2. 6 दो ही फेस में. यहाँ पर 6 फेस में था इसलिए into 6 यहाँ पर 2 फेस में था. Therefore Z equals to 1 plus 1 again Z equals to 2. So these are the number of particles per unit cell. A simple cubic cell में altogether there is 1 particle per unit cell. Face centered में there are 4 particles per unit cell. Body centered में there are 2 particles per unit cell. And N centered again there are 2 particles per unit cell. Okay, Isha is understood? Isha, are you there? Okay, Rishad, are you getting this?
Yes, sir.
Okay, Rahul, Pratyush, I thought, why am I asking you so much? Because yes, these are important, right? Chalo. So now we have a visualization about each type of unit cell. Now we can clearly visualize. अब मैं numericals में आऊँगा. ठीक है? So have you copied it?
Sir.
Chalo. You write it down along with me. So I'm rubbing this and I'm rubbing this. So I hope you all have copied it. So I'll just do one numerical today. Okay, then I'll continue in the next class. Okay. So you have come across this type of questions, right? School में किया होगा ऐसा discuss
Yes.
किया था? Okay. Are you? Can you do this type of problems?
Sir.
Now you can do easily. आँख बंद कर पाओगे. Now you guys are becoming expert. Pro level में चले गए तुम लोग, ठीक है? Solid state का. You guys are in the pro level, eh? Yeah. Are you all in the pro level? Right. Huh? Pro level, huh? Okay. So the question says a cubic solid is made up of two elements. Okay, it is made up of X and Y. Where are X present? Where are element X present at the corners? And why are elements? Where are elements Y present at the center of face? Now I'll write it down. You give me the answer. Okay. So number of atoms X. How many atoms of X are present? Where are the atoms X present?
8 into 1 by
Where are
8
the atoms X present?
corners.
Corner. So how many atoms of X are present?
8 into 1 by 8, 1.
Good. All X are present at the corners. 8 corners represent X. Contribution of one corner is 1 by 8. There are 8 corners. There is equal to into 8 equals to 1. Very good. Fine. Now, number of atoms Y कितना होगा?
1 by 8 into 8 plus 1 by 2.
Y are present at the face center. Face center का contribution कितना है?
1 by 2 into 6.
1 by 2. How many such faces are present?
6.
6. What is the formula? What is how many?
3.
3. So how many X are present?
1.
1. How many Y are present?
3.
Therefore, the formula of the compound is X, Y, 3. What could get more easier than this, guys? What can get more easier than this? Yes. Yeah, tell me. Okay. So, find the formula of the compound. If one particle is missing from one of the faces, कैसे करोगे फिर? So I have just added this line. Find the formula if of the compound if one particle is missing from one face.
One face but missing from the
Usually,
then 1 by 2 into
usually how many particles are present in how many faces are there?
1 by
how many faces are there? How many faces are there?
6.
So there are 6 particles at 6 faces. एक face से एक particle missing है. So how many
5.
particles are present at the faces?
So
कितना
5.
faces particles present है? 5.
5.
5. So number of atoms Y will be contribution of one face particle will be half. Now particles are present only at the 5 faces, not 6.
Into 5.
And 8 face से the particle missing है. 8 face से the particle missing है. So it will be half into 5. So this will be 5 by 2. Got it?
5 by 2.
Yes.
Got it?
Yes, sir.
8 particle missing है. So formula will be X, Y, 5 by 2. But we usually don't write the formula like this. How do you convert this into whole number? We multiply both
Yeah.
X 5 by 2. दो से multiply करो. So it will be X to what?
2.
Y 10.
X 2 Y 5.
Sorry, Y 5.
Y 10.
Y 5. We are multiplying by 2. So this is the formula of the compound. Okay.
Yes.
Yeah.
Sir.
It's so interesting. Now the next class is going to be really interesting. Okay, I'll immediately send you those videos. You go through it once more. I hope this class is fruitful. I think it's understood.
Yes, sir.
मजा है, सर, मजा है.
All of you, tell this
Yes,
girl
sir.
not to